Alright, so let's move back to slides, and we have a query optimization, which will be the focus of this section. Normally, when we are talking about a new section, we need to ask what's the motivation, why we have to start this section. Right? And in this page, we show you the motivations why we need to start this new section. So normally, when we do the query processing, the query optimization is usually at the heart of the database engine, because when we have query input, we need to convert this query SQL language into some logical plans, as we mentioned before, right? Via the query compilers. The compiler can translate these queries from SQL to some logical plans, as well as some other information for the logical plans, right? Like the tree structure, something like that, right? We mentioned before. And normally, when we have the logical plans, another step we need to focus on will be find a better logical plan and find an associated physical plan as well. And we have multiple ways to address SQL queries. Which one is better or the best, which will be the focus of this section. And when we have a better or best logical plans, then we can execute the queries in a much faster and efficient way in both time cost as well as the physical disk I/O cost as well. So that's the reason why we want to start this section actually. So as we mentioned before, right, when we have some query input in SQL, we need to translate this query into the logical plans. In this page, we show you with the example, right? Let's assume we have a query input on the left-hand side, the top side. We want to select A1 to AN. This A1 to AN are the attributes we want to select, right? And from R1 to RK, this R1 to RK, these are the relations we are starting here, right? Where C denotes a condition. So this query denotes we want to project some attributes from several relations and based on some conditions, right? This C denotes condition. And if we translate this query from SQL to the relational algebra, we can represent this query as this projection A1 to AN. These are the target attributes we are interested in, right? A1 to AN, we do the projection here. However, inside it, we have the joins among these relations. And here we have some condition for the joins, right? Therefore, we have this selection C. C denotes a selection condition, right? And inside it, we have R1 times R2 until RK, right? This denotes the joins among these K relations based on condition C, and we want to further project this A1 to AN, these attributes. This is the relational algebra expression we can represent this query, right? They are the identical representations. Furthermore, we can also represent this expression as an expression tree as well, right? So given R1 to RK, these relations, and we can do this as selection based on it, and we can further apply this projection in the tree, right? To represent these expressions. And formally, this tree or this relational algebra expression can denote this logical plan of this query when we are doing executions. Inside, we need to first execute or compute this product among these relations first, and then we do the selection according to the condition C, and then we can do the projection according to the attributes, right? So this denotes how we will process these queries in several steps. This is one example. Another example we show here is select A1 to AN. They're the same. From R1 to RK, we will condition C. However, here we have one more row here, which will be the group by B1 to BM. B1 to BM, they are also the attributes from R1 to RK, these relations. And we are grouping all the instances or tuples according to B1 to BM, these kinds of attributes, and then we can further do the selection as well as projection. And we can represent these kinds of queries as a relational algebra on the right-hand side. Let's assume we have several relations R1 to RK. Inside it, we have this selection according to condition C, right? Which will also be equivalent to joins among these relations according to some conditions. And here between this projection as well as selection, we have one more layer or one more operator, which will be the group by, right? The group by B1 to BM, and normally we also have some aggregation operators here. So here we use gamma B1 to BM, denoting the grouping of the tuples according to these attributes, and we have one more aggregation operator here. And outside we will have one more projection, right? A1 to AN. And so this will be the relational algebra expression of this query, and we can also represent this expression as a logical plan or logic tree as well, which will be, denoting the query execution process of this query, right? Okay, so this is the way when we are converting SQL to the logical plans, and here for simplification, we use these relational algebra expressions to denote these logical plans here in the examples. Alright, So, based on some examples like this, we will show you how to do the optimization of the network plans in the following pages.